Solve the following quadratic equations by using the square root property. The first one example here, we have x squared equals 49. So the square root property says that you can take the square root of both sides of an equation, but if you involve taking the square root of a variable, you have to consider that you may have a positive or negative value as a result, because you don't know if the original variable was positive or if it was negative. So you just consider both cases. So square root of x squared reduces to just x. Square root of 49 is 7. So this is plus or minus 7. And the meaning here is that if you square positive 7, you get 49. And if you square negative 7, you get 49. So you do have to consider both potential cases. Next up, we have x minus 5 quantity squared equals negative 28. Now, in this case right here, if I apply the square root property, then effectively my first step is to take the square root of both sides of this equation and consider the positive or negative case on the constant. All right, so the square and the square root cancel, leaving me with just x minus 5 and the square root of negative 28. Now, if we were not considering complex values as potential solutions, then we'd basically be done here because the square root of a negative number is not technically defined in the real numbers. But in this case, we are considering the possibility of complex solutions. So we will allow the negative underneath the square root to be pulled out as I. So initially, this is going to be I square root of 28. And then what I'm going to do to get x by itself is add 5 to both sides. So x equals 5 plus or minus I times, and then the square root of 28 could probably be reduced a little bit. So 28 itself is not a perfect square, but 28 is 4 times 7. And if you have the square root of 28 underneath the square root and could write that as the square root of 4 times 7, you can break this up into the square root of 4 times the square root of 7, which would be 2 times the square root of 7. So what I'm going to do here is write this as 2i square root of 7. Lastly, we have 5x squared minus 7 equals negative 97. So to get the point where we can take a square root of both sides, the first thing we need to do is get that square by itself. So I would need to add 7 to both sides to start off. So that gives me 5x squared equals negative 90. And after that, I still have this multiplying 5, which I need to divide from both sides and get rid of. So negative 90 divided by 5 is negative 18. And when I take, now that I have the square by itself, I can take the square root of both sides. So the square root of x squared equals the plus or minus square root of this constant value over here, or x equals plus or minus, the negative can come out as an I, and then we have 18. So 18 could be written as 2 times 9, and 9 is a perfect square, so I can pull that out from underneath the square root as long as I make it a 3. So this would be 3 square root of 2, and it's a little bit more common to put the constant first and then the I and then the root. So I'll write it this way as my final answer.